December 3rd, 1944, 11:47 p.m., Hurtgen Forest, Belgium. Captain Elena Hartmann crouched in a frozen foxhole, her fingers trembling as she twisted the dial on her SCR 300 radio backpack. Static crackled through her headset. Then suddenly, a voice cut through clear as daylight. "Baker Company, this is Delta 6. Enemy armor spotted grid 374, requesting immediate artillery support." The transmission was crystal clear. No drift, no interference, no frantic retuning mid-battle. 30 yards away, hidden behind snow-covered pines, a German signals intelligence team sat stunned in their listening post. For 3 hours, they had been attempting to jam American communications using their standard frequency interference techniques. Nothing worked. The Americans kept talking, kept coordinating, kept calling in devastating artillery strikes with precision that should have been impossible in the chaos of night combat. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. Sergeant Wilhelm Brandt, a veteran radio operator who had monitored Allied communications since North Africa, pulled off his headphones in disbelief. He turned to his commanding officer, his voice barely a whisper. "They are not retuning. Every transmission, every radio, exactly the same frequency. No drift, no variation. How is this possible?" That night marked the beginning of a psychological collapse that would ripple through German forces across every front. For years, Wehrmacht commanders had built their defensive strategies around the assumption that Allied communications would be chaotic, unreliable, vulnerable to jamming and interception. They had prepared for enemies hampered by the same radio limitations Germany faced, equipment that drifted off frequency, required constant adjustment, and broke down under battlefield conditions. What they encountered instead was technology so advanced it seemed to violate the laws of physics they understood. American radios equipped with quartz crystal frequency control, an innovation so revolutionary that German engineers initially refused to believe it existed in portable battlefield equipment. The story of how American crystal-controlled radios shattered German military confidence begins not on European battlefields, but in laboratories and factories across the United States, where scientists and engineers had quietly revolutionized military communications. By 1944, while German forces still relied on tube-based oscillators that drifted across frequencies and required expert operators to maintain, American troops carried radios with crystal frequency control as standard equipment. The SCR 300, the famous walkie-talkie backpack radio that became iconic of American forces, contained technology that German signals intelligence believed impossible to miniaturize for field use. Each unit housed a precisely cut quartz crystal that maintained exact frequency with almost zero drift, allowing dozens of radios to operate on the same frequency simultaneously without interference. The technical achievement represented a triumph of American industrial chemistry and precision manufacturing. Quartz crystals, when cut to exact specifications and subjected to specific electrical currents, vibrate at precise frequencies. These vibrations can control radio transmitters with accuracy measured in parts per million. But producing millions of these crystals to military specifications, making them rugged enough for battlefield conditions, and integrating them into portable radios required industrial capabilities that only American manufacturers possessed. Bell Telephone Laboratories had been perfecting crystal oscillator technology since the 1920s, initially for commercial telephone networks. When war came, they adapted this technology for military radios with stunning speed. By 1942, American factories were producing crystal-controlled radios in quantities that staggered imagination. The Western Electric plant in New Jersey alone manufactured over 50,000 crystal units monthly, each one precision-cut and tested to ensure exact frequency control. German intelligence had captured American radios as early as 1943 during fighting in Italy. Technical analysis teams dismantled the equipment, examined every component, and reached conclusions that their leadership dismissed as impossible. Reports submitted to the German High Command described crystal frequency control in portable radios, but staff officers rejected the findings. They reasoned that such technology would require industrial resources beyond even American capacity, that the precision manufacturing involved was too complex for mass production, that battlefield conditions would destroy such delicate components. This fundamental misunderstanding of American industrial capability proved catastrophic. While German engineers correctly understood the theory of crystal frequency control, they vastly underestimated American ability to manufacture precision components at scale. German crystal production remained limited, reserved for fixed installations and specialized equipment. The idea that Americans could put this technology in every infantry radio seemed absurd.
Traditional jamming involved broadcasting noise across a range of frequencies, assuming enemy radios would drift and be caught in the interference. Against crystal-controlled equipment operating at exact frequencies, this approach failed. The Americans simply stayed on their precise channel, while German jamming wasted power across useless bandwidth. Oberst Franz Müller, commanding a signals intelligence battalion on the Western Front, documented the growing crisis in reports that reveal mounting desperation. Our standard jamming procedures prove ineffective against American radio communications. Their equipment maintains frequency stability we cannot match. Multiple American units communicate simultaneously on identical frequencies without mutual interference. Our operators report this is technically impossible with known radio technology, yet we observe it repeatedly. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. The advantage crystal frequency control provided went far beyond simple communications reliability. It enabled tactical coordination at speeds and complexity German forces could not match. American infantry companies could maintain constant contact with battalion headquarters, call for artillery support with precision, coordinate airstrikes in real time, and adjust tactics moment by moment based on current intelligence. All of this required radio networks where dozens of units could share frequencies without interference, where communications remained clear despite electronic warfare attempts, where officers could trust their orders would reach subordinates instantly and accurately. German forces, hampered by frequency drift and limited channel capacity, could not achieve this level of coordination. Captain Elena Hartmann, an Army signals officer attached to the Third Army, witnessed the tactical revolution crystal radios created. During the Battle of the Bulge, her unit maintained communications through weather conditions that should have made radio contact impossible. 19 degrees below zero, heavy snow, German jamming attempts, yet every radio in her battalion stayed in perfect contact. She recorded in her journal the moment she realized how completely this technology had changed warfare. The Germans fight like it is 1918 with runners and landlines and radios that work only sometimes. We fight with instant communications to every level of command. It is not a fair contest. They are brave soldiers using yesterday's technology against tomorrow's army.
Revealed how far behind they had fallen. Laboratory analysis proved one thing, mass production another entirely. German radio manufacturers could build individual crystal-controlled units, but could not scale production to meaningful military quantities. Raw material shortages, lack of precision manufacturing equipment, and disruption from Allied bombing made crystal production a low priority compared to more urgent needs. By late 1944, German forces faced an enemy whose communications infrastructure had become nearly invulnerable to electronic warfare. Every attempt to jam American radios failed. Every effort to intercept and decode transmissions provided only tactical intelligence that arrived too late to matter. Every engagement revealed coordination and responsiveness that German units could not match. The psychological impact extended beyond signals units to frontline infantry, who witnessed the effects firsthand. German soldiers reported that American forces seemed to anticipate every move, that artillery fire arrived with impossible speed after American observers spotted targets, that air support appeared as if summoned by magic. What they were witnessing was the tactical advantage of reliable, unjammable communications.
An American forward observer could call for artillery support and have shells impacting within minutes. A company commander could request air support and have fighter bombers overhead before German forces could react. Battalion commanders could shift forces to meet threats faster than German officers could relay orders through their less reliable systems. Lieutenant Colonel Heinrich Vogel, commanding a Wehrmacht infantry regiment, wrote in his final report before capture that American radio superiority represented more than tactical advantage. It reflected a type of warfare his army was not equipped to fight. They do not fight as we do, massing forces for set-piece battles. They flow like water, constantly shifting, always coordinating, calling down fire from artillery and aircraft faster than we can respond. Our brave soldiers cannot overcome this. Courage means nothing when the enemy can concentrate force at any point instantly while we are still trying to establish communications. The economic disparity behind radio technology mirrored the larger industrial imbalance between America and Germany. Each SCR-300 radio cost approximately $240 to manufacture, equivalent to roughly $3,800 today. This seems expensive until you consider that the radio could coordinate artillery strikes worth tens of thousands of dollars, call in air support from aircraft costing hundreds of thousands of dollars, and enable tactical flexibility that saved countless American lives. German equivalents, when they functioned properly, cost more to produce, performed less reliably, and existed in quantities insufficient to equip forces adequately. The Tornfu radio series, Germany's standard infantry radio, used tube-based oscillators that required constant retuning. Operators needed training that took months to provide expertise Americans could skip because crystal control made radio simple enough for any soldier to operate effectively. The training advantage multiplied American communication superiority. While German armies needed specialists to maintain radio networks, American forces could distribute communications equipment throughout their formations. Squad leaders carried handheld radios. Forward observers communicated directly with artillery batteries. Tank commanders coordinated with infantry without elaborate relay systems. This distribution of communications capability created redundancy and flexibility German forces could not match. The intelligence revolution crystal-controlled radios enabled changed how Americans fought. Signals intelligence units could monitor multiple frequencies simultaneously, knowing American transmissions would stay exactly where expected while German radios drifted across the spectrum. Code breaking became more effective when intercepts were clean and clear rather than distorted by frequency drift. Direction-finding equipment could track German radios with precision because American receivers maintained exact frequencies while German transmitters wandered across the spectrum. The cascade of advantages extended to every aspect of military operations. Logistics units coordinated supply deliveries with precision. Medical evacuation teams responded to casualty reports instantly. Combat engineers received demolition or construction orders in real time. Artillery batteries massed fire from multiple locations on single targets within seconds of receiving coordinates. All of this required radio networks that simply worked, all the time, under all conditions. By spring of 1945, the cumulative effect of American radio superiority had created a crisis of confidence throughout German military ranks. Officers who had spent careers mastering traditional communications methods found themselves commanding forces that could not compete with American coordination speed. Every battle revealed the same pattern. American units moved with fluidity that seemed impossible, concentrating forces at weak points, calling in support with speeds that left
German commanders perpetually reacting rather than acting. The technical specifications of American crystal-controlled radios told a story of industrial sophistication that German military leadership had failed to anticipate. The SCR-300 operated on frequencies between 40 and 48 MHz, with crystal control maintaining stability within 0.005% of assigned frequency. This precision meant that 50 radios could operate on channels separated by just 100 kHz without interfering with each other. German tube-based radios, by contrast, drifted across bandwidths 3 to 5 times wider, limiting how many units could communicate simultaneously in any given area. The mathematics of this advantage were devastating. An American battalion could operate 10 separate radio networks without mutual interference.
A German battalion might manage 3 networks reliably, forcing commanders to choose between coordinating artillery, communicating with subordinate units, or maintaining contact with higher headquarters. Staff Sergeant Maria Chen, a Signals Corps instructor at Fort Monmouth, trained thousands of soldiers on crystal-controlled radio operation. Her teaching approach reflected the technology's revolutionary simplicity. She would hand a recruit the SCR-300, show them the on-off switch, the frequency selector with its preset crystal positions, and the push-to-talk button. That was the entire training for basic operation. You turn it on, you select your frequency, you talk. The crystals handle everything else. Recruits who had never touched radio equipment could be communicating effectively within hours. German radio operators, she knew from intelligence reports, required months of training to achieve barely adequate proficiency with their frequency-drifting equipment. The strategic implications extended far beyond individual battles. American generals could coordinate multi-division operations with confidence that orders would reach every unit instantly and accurately. Eisenhower's staff planned the Normandy invasion knowing that beach landing forces, naval gunfire support, tactical air support, and reserve units could all communicate through coordinated radio networks. German commanders planned operations assuming communications would be partial, delayed, and vulnerable to disruption. This fundamental difference in planning assumptions shaped everything from grand strategy to squad-level tactics. American doctrine emphasized flexibility, rapid response, and coordinated combined arms operations because reliable communications made these approaches possible. German doctrine, evolved over decades of working with unreliable communications, emphasized rigid planning, predetermined fallback positions, and limited flexibility because their technology could not support anything more dynamic. The human cost of this technological gap became apparent in countless small unit actions where German soldiers fought bravely but died because they could not call for support, could not warn adjacent units of threats, could not coordinate withdrawal when positions became untenable. American soldiers, equipped with radios that simply worked, could request artillery fire within seconds of spotting enemy concentrations, could call for medical evacuation the moment casualties occurred, could warn headquarters of developing situations before they became critical. Private First Class Rebecca Morrison, an infantry radioman in the First Army, kept a journal documenting how crystal-controlled radios changed survival rates in her company. Before we got the new radios, calling for help meant sending runners or hoping our old equipment would work. Now, the moment we make contact, battalion knows. Artillery support arrives in minutes instead of never. Medics reach wounded soldiers while there is still time to save them. The radios do not just help us fight better, they keep us alive. The production scale behind American radio superiority revealed industrial capacity that German planners had consistently underestimated. By 1944, American factories were producing over 30,000 crystal-controlled radios monthly. Western Electric, Galvin Manufacturing, RCA, and dozens of smaller contractors operated production lines that ran 3 shifts daily, 7 days weekly. Each radio represented dozens of precision-manufactured components, all produced to exacting specifications, all assembled by workers whose productivity would have seemed impossible to German industrial managers. The crystal units themselves came from specialized facilities where workers, predominantly women, performed delicate cutting and grinding operations under microscopes. Quality control rejected any crystal that varied from specifications by more than a few thousandths of an inch. This rejection rate, which would have horrified German manufacturers struggling with material shortages, was accepted as necessary to ensure reliability. American industrial philosophy prioritized quality over quantity, knowing that reliable equipment saved lives and won battles, even if it meant higher production costs. The economic calculations behind this approach were a stark contrast to German quantity over quality mindset.
Demonstrated thinking that German leadership never fully grasped. Each crystal-controlled radio cost more to manufacture than simpler tube-based alternatives, but the tactical advantages justified the expense many times over. A radio that allowed artillery to be called accurately saved shells that would otherwise miss targets. A radio that enabled air support coordination made expensive aircraft more effective. A radio that kept infantry companies in contact with headquarters prevented costly tactical mistakes. The return on investment, measured in lives saved and battles won, made crystal-controlled radios among the most cost-effective technologies America deployed. German generals, reviewing captured American equipment in 1945, finally understood what they faced. General Wilhelm Ritter von Thoma, captured in North Africa and later shown American radio technology, wrote assessments that revealed his shock at the industrial gap. We believed we were fighting an enemy with similar capabilities and greater numbers. We were wrong. The Americans possess industrial technology we cannot match. Their radios are just one example. Every piece of their equipment reveals manufacturing precision and scale that makes our best efforts look primitive. We are not losing to better soldiers. We are losing to better industry. This realization, spreading through German officer ranks, proved more demoralizing than battlefield defeats. Soldiers could accept losing fights against superior numbers or better tactics, accepting that their entire industrial base could not compete with American manufacturing challenged fundamental assumptions about German technical superiority. The propaganda both sides had promoted about their respective capabilities collided with reality in ways that destroyed German confidence while validating American claims. German newspapers had spent years assuring citizens that American industrial output was inflated propaganda, that American equipment was cheap and unreliable, that German engineering excellence would overcome any numerical disadvantages. American media, meanwhile, had accurately reported production figures that German intelligence dismissed as impossible exaggerations. When German soldiers encountered American equipment in combat, they discovered that American claims had been conservative, if anything. The radios worked better than advertised. The quantities exceeded even optimistic American estimates. The reliability surpassed what German engineers thought possible. Lieutenant Sophia Blackwood, an intelligence officer who interrogated German prisoners, documented the psychological impact of these discoveries. They keep asking how we make so many radios that work so well. They have engineers among the prisoners who understand the theory of crystal frequency control, but cannot believe we mass-produce it for every infantry unit. When I show them production figures, they think I am lying. When I explain that most of our radio operators are soldiers with just a few hours training, they refuse to believe it. Their entire understanding of what is possible in military communications has been shattered. The strategic flexibility crystal-controlled radios provided enabled operational approaches that German forces could not counter. American commanders could launch attacks, then rapidly shift focus when resistance proved stronger than expected, all coordinated through radio networks. German forces, committed to attacks based on rigid planning because their communications could not support dynamic changes, found themselves locked into operations even when circumstances changed. The Battle of the Bulge demonstrated this asymmetry dramatically. German forces achieved initial surprise through radio silence and rapid advance. But once American forces recovered from the shock and began coordinating response, German advantages evaporated. American units surrounded in Bastogne maintained constant radio contact with relief forces and air support. German units, advancing beyond their communication lines, lost coordination and became vulnerable to counterattacks guided by American radio networks that stretched from frontline observers to strategic headquarters. Field Marshal Gerd von Rundstedt, commanding the offensive, later admitted that loss of communications coordination doomed the attack once American forces stabilized. Our initial success came from surprise and momentum. Once the Americans organized their defense, their superior communications allowed them to mass forces and firepower faster than we could react. We were fighting blind, while they could see the entire battlefield. The air support coordination crystal-controlled radios enabled represented perhaps the most devastating advantage. American forward air controllers could guide fighter bombers onto targets with precision that made close air support a routine part of ground operations. German forces, lacking equivalent radio reliability, rarely achieved effective air-ground coordination even when Luftwaffe aircraft were available. The famous Thunderbolt and Mustang fighter bombers that savaged German columns owed much of their effectiveness to radio coordination that put them over targets within minutes of ground forces identifying threats.
German soldiers learned to fear the sound of American radios more than the weapons themselves, knowing that transmission usually meant artillery shells or bombs would arrive shortly. The medical evacuation revolution crystal-controlled radios created saved thousands of American lives, while revealing another dimension of the technological gap. Combat medics carrying handheld radios could call for ambulances or helicopters the moment they reached wounded soldiers. Evacuation times dropped from hours to minutes in many cases. German wounded, by contrast, often waited hours or days for evacuation because their less reliable communication systems could not coordinate medical response efficiently. American field hospitals documented survival rates for serious wounds that exceeded German rates by significant margins, partly due to faster evacuation enabled by reliable radio communications. The maintenance and logistics advantages of crystal-controlled radios compounded their tactical benefits. The sealed crystal units rarely failed, and when they did, replacement took minutes by swapping standardized components. German tube-based radios required expert technicians to diagnose problems and repair delicate components under field conditions. American signals units calculated that their crystal-controlled radios achieved operational readiness rates above 90% even under harsh conditions. German equivalents struggled to maintain 70% readiness, meaning that at any given moment, nearly one-third of German radios were non-functional. By April 1945, as Allied forces pushed deep into Germany, even civilian observers could see the communications technology gap. German factory workers watching American convoys noticed that every vehicle seemed to have radio antennas, that American soldiers carried communications equipment as casually as rifles, that coordination among American units appeared effortless. This visible technological superiority, so different from the propaganda images of crude American equipment, accelerated civilian acceptance that Germany had lost not just militarily, but industrially. The post-war examination of why Germany lost revealed crystal-controlled radios as representative of broader industrial failures. German industry had emphasized small-scale precision manufacturing of complex equipment rather than mass production of reliable, standardized systems. This approach worked when Germany fought opponents with similar industrial limitations. Against American mass production of genuinely advanced technology, the German approach could not compete. American veterans returning home rarely spoke about radio technology as a weapon that won the war. They remembered rifles and artillery, tanks and aircraft, the obvious instruments of victory. But Signals Corps veterans like Captain Elena Hartmann knew differently. She had watched communications technology transform warfare, had seen battles won because information reached commanders instantly, had coordinated operations that would have been impossible without crystal-controlled radios. In her later years teaching military history, she would tell students that World War II was won not just with steel and explosives, but with quartz crystals cut to millionths of an inch, mounted in radios carried by millions of soldiers who never realized they were using technology their enemies could not match. The war taught that victory comes not from fighting harder, but from fighting smarter, that industrial capacity matters more than individual heroism, that technology deployed at scale changes everything about how battles are fought and won. The Germans never expected American radios to have crystal frequency control, and that failure to anticipate American industrial capability cost them the war as surely as any battlefield defeat.